Good evening, guys, and welcome to the Advanced Refrigeration Podcast, continued EMS training on the Emerson E2 controller. Today we are going to be going over digital sensor controls and digital combiners, how to program them, what to use them for, and what to look out for. So we're going to be going over the program in terminal mode and in ultrasight. So like always, guys, we're going to log into the controller. Once we're logged in, we are going to go to the menu. We are going to go to 6, which is add or delete application. We're going to add an application, and we're going to hit lookup. And we are going to choose a digital sensor control. Now you have a digital sensor control and you have a digital combiner. We're going to go over both of them and why you'd use one over the other. So first things first is a digital sensor control. Now the difference between a digital sensor control and an analog sensor control is a digital sensor control is going to be on or it's going to be off. So whereas an analog sensor control is going to have a varying signal, whether it be voltage, current, temp sensor, anything like that. Anything that varies is going to be analog. Anything that's on or it's off is going to be digital. So whether it's a physical switch, a defrost termination, level, anything in the controller that is on or it's off, whether it be a physical board point or it's a networked variable. So first things first is, like always, we have a general screen. So name, we'll call it test 1. Or, we'll call it, we'll knock out 2 birds with 1 stone. We'll call it defrost diff valve. So long name, we'll call it defrost. Okay, so just like this, you have number of inputs up to 4. So we'll go with 2 this time. And then you have combination method. So if you hit F4 look up, so you have AND, which means both have to be on. So it'd be input 1 and input 2 have to be on for it to make its closure. You have OR, which would be input 1 or input 2 have to be on for it to be on. You have XOR, so it's OR and NOR. You have vote, so we can take a vote of how many inputs are on and how many inputs are off, and whichever one has the highest number. So if you have 2 inputs on and 2 inputs off, it's gonna error out. If you have 3 inputs on and 1 input off, it's going to be on. And then you have first. So whatever input is on or off first will be your deciding factor. So with this one, we're going to go with OR. Okay, so you can invert control value, meaning the control value could be backwards. So whatever you need it to be. So if you had 2 things that were on all the time and you needed them to be off to make it be on, so you can invert the control value that way. And if you look at the definition for this, so if desired, you may invert the combined digital value immediately after the digital combiner cell. Combines the logic inputs. To do this, enter yes. This field will leave combined values unaltered, no. If this field is set to yes, combined values of on will be changed to off, and combined values of off will be changed to on. Meaning it'll just switch around whatever it is, whether it's on or it's off. It'll do the opposite. So if we go down here, you can go to show advanced. You can click yes, and then you have scheduled mode. So This is the primary means used by the schedule interface cell to combine the occupancy input with the combined value calculated by the DV combiner cell. There are 6 options: logic only, schedule cell, it ignores the scheduled input and passes along combined value from the DV combiner cell unaltered. This is equivalent to disabling the SCIF cell. Schedule only, SCIF cell ignores the combined value from the DV combiner cell and passes along this scheduled input combined command value. This is equivalent to disabling the DV combiner cell and using the scheduled input as a primary. So you can read both of these. I mean, I don't use this very often. I mean, this is some stuff when you're doing some upper level stuff. So if you ever want to know what something is, you could just click the question mark on it. So alternative method, you have logic only, you could hit lookup, you could change it to schedule, both on and off, any, schedule only, logic only. This is your scheduled backup. Emergency control value. So you could change this to off, or you could change it to on, or you could write a point to it. So if you need to override it in the emergency tab. So next is going to be our logic in. This is where your board points would go, or your logic in. So right now we're going to hit, so we're only set up for board and points right now. Right now we're going to edit it. We're going to go to alternative IO formats, and we're going to go to area control. Since we're going to be taking these inputs from an actual control. So we're going to choose the condenser. We're choosing this E2. We're going to choose the enhanced suction. And we are going to choose group liquid-line solenoid. And then we're going to go down to this one. Same thing. See, it went back to board and point. This top one is area control. So now we're going to edit again. We're going to alternative IO formats. We're going to go area control because we're going to tie it to an application. Look up, choose this controller. Go to the application. We're going to hit look up again. And we are going to scroll down. Without trying to overload this thing like we did in the past. See if I got one. There it is. Rack A condenser control. Oh, Rack A enhanced suction. Okay, then we're going to choose this group liquid-line solenoid. So this is what I was talking about in a previous video. When you have multiple racks on or suction groups on the same controller, and it's the same rack. So meaning so if you have rack A, so you had a plus 23, a plus 28, and a minus 10 suction. Well, say you have multiple hot gas circuits spread out between them. Now you have the same group liquid-line solenoid for this. So in the E2, you can only control an output from one input, meaning one application can only control an output. So now you would either have to link all the cases back to one suction group in order for the defrost differential valve to turn on, or you would do a digital sensor control. So we're going to do an OR. So that way, if input 1 or input 2 is on, meaning it's calling for the group liquid-line solenoid or defrost differential valve in that group to be on, it's going to close and let that input energize and then control the liquid-line solenoid or defrost differential valve. So we got our inputs. So use alternative combo. So these are your other control ends. We're not using that. So if you wanted to control your emergency override on the first screen where it was off, you could change it to on if you need to. You could have the emergency override wrote in there to an input, alarm disable, suspend count, reset count. Same thing like the analog sensor control. You have a counting in here, and you have an enable. So you could suspend the count or reset the count if you're actually counting how many times something cycles. So you could use a timer to cycle the reset count. So if you're trying to see how many times something's cycled on so many times at a digital point, a day or an hour or a minute, you could do it with a digital sensor control in the counter. So you have your minute delays. So you have minimum on time, minimum off time, and then your on delay and off delay. So I mean, you could use this for a compressor, an unloader, a single system if you're doing some fans, if you're doing some defrost termination. So anything that is a digital sensor. So if we go to the next tab, we got our proof. So you could have a proof tied into this. So you could have a proof type and a proof input. So if you hit look up under here and you hit logical value, so you have a proof input. So you could have a separate, it tagged another input in here. So you could have a proof. So say if you're using it for something else, you could tie the proof into it. If you're needing to prove that something's on. So say you're using this for like a heater reset or a heater proof, and you want the heater to be on. If the logic's made, you want to proof it in to make sure it's actually on. So then you also have proof fail, proof latch, proof delay. You have proof when on, proof when off, clear, any, match, yes, no, proof priority. So all that's in here. Not something you use a whole lot. I mean, you could use it on some defrost stuff. I mean, don't use a ton of digital sensor controls. They have their place, and not a whole lot of proof stuff done in them. So again, in here on the outputs, you have your command out. So that's going to be where you tie your board point to, just like in the analog sensor control. And then in here, command when on. So you could change this. So when the control value is on, you could change this to off. When the control value is off, you could change it to on. So same thing with alarm. You could put not active in here, not active in here. The newer versions is none. Same thing with notices. And then all these points down here, the cycles, trip, control value, just like the analog sensor control, that's going to be your loggable points. That's going to be if you're using the counting feature and you're actually counting how many times something cycles and all that. So we move on to the next tab, which is going to be the count and pulse. So on the count and pulse, you have the initial count. So and then cycle trip point. So a 1 is how many times it has to cycle before it trips. Counter type reset is level. So level means anytime it goes from on to off or off to on, it's going to count. So if you hit here, look up, and then edge, level is a change of state, and then edge is when it cycles from on to off, and then NV edge is off to on. So if you click here, sorry, edge is off to on. Yeah, like I said, NV edge is on to off. So you're going to see these NV edge, and level a lot as we move forward. As we start getting into more advanced stuff and we start bringing up flexible combiners and we start going through that document, a lot of that is going to be in there. So a lot of this analog sensor control stuff and digital sensor control stuff, we're building up until we get to the flexible combiner, which is going to be our custom logic. This is more like boxed logic, simpler stuff for guys to be able to do stuff. So if you go to pulse type, this parameter determines under what conditions a one-shot cell will generate a pulse. There are 4 options: disable, no pulses, edge, the one-shot cell will pulse a single on signal every time the logic command value is on, transitions from off to on. NV edge, same thing as we talked about earlier. So this is for pulsing the output. If you wanted to use it as a pulse type output. So if we hit lookup and we go edge, so, and this is the pulse width. So it'll pulse it on for a minute and then off when it switches back, then on for a minute. So this would be useful for if you're trying to do some like liquid injection, oil pulsing. So if you wanted to pulse an oil solenoid every time a level switch made and you wanted to drain a reservoir into another tank, you could do that. Or say every time a level switch made, you wanted to pulse a solenoid on for 30 seconds, you could do it like this. This is where a pulse comes in handy, and this is where like a sensor control could be made very easily, accessible and workable than doing a flexible combiner. Like, it's a lot easier for a guy to troubleshoot one application where it's all in here. So if we go to the next tab, and this is your bypass value. So you get your bypass input, and your bypass value could be this is a standard just value. So if you go to alternative IO formats, you could change that to a fixed value like it is now, or you could change it to an area control. You wouldn't want to change it to a board and point, but you could change it to a fixed value like it is now, on, off, not active. And then your bypass input's going to be down here. So if you go to your next tab, you get your alarms. Just like everything else, the analog sensor control, you got your alarms in here. So all your alarms are in here, whether it's on, it's off, it's an alarm, your alarm priorities. You get the next tab, you got your KW stuff. Like I said, we're not really using this stuff to bump KW. So that's how you do a basic sensor control, digital sensor control. So if we go to sensors, now it's going to be under the sensors tab. So we go down here and we go to defrost differential valve. Okay, so this is our screen. So we have two inputs, our combination methods, or we're not using any of the logic face modes, haven't set up any alarms. So if we go to the first value and I click it, I gotta go down, I'm not on ultrasite. So if I hit enter, I go to override and I go yes, and I go on. See how input 1 is on, input 2 is off. Now it's on. So if we go likewise, we go down here, we override this to on. So if both suction groups were to call for the defrost differential valve to be on, it would be on. If one suction group calls for it to be off and the other one's on, it's going to be on. So if they both call for it to be off, it's going to be off. See, it's still on. See, and then we have a cycle counter. So it's cycled one time. If we go down here and we cycle this guy off, change this to no. So it's cycled off. See, it's an alarm because we have the command on off. So it just switched. So that same thing, if you change your update rate, it'll do that. If you were to change this to and, I'll show you how it reacts. So if we go down here and we hit F4 lookup and we change this to and. Okay, so they are both off. So it is going to be off. So let's change the first one to on. Okay, first one's on. Out, the command out is still off. So over here. So one is on, the second one is off. So if we go to that one and we override it, so they're both on now. See, we cycle tripped because they both turned on. Command out's on. So that would be an AND value. So an AND is both have to be on for the control value to equal on. If one of them turns off, it's going to be false now, and it's going to be off. See, control value turned to off, and the command's going to also switch off here in a second. So we have it set up for pulsing still, so as soon as it pulses off, see, it turned off. As soon as the pulse turns off. But that is a digital sensor control. Like I said, this is one common thing for it. I use it a lot for compressor proofs, compressor cycle counting. So in the E2, you only carry cycles for the day for 24 hours. So you could set up digital logging to where it gives you longer, like a week or 2 weeks. I do a lot of stuff where I'll set up each individual compressor cycle counts in the controller, and I will count it and I will reset it every week, so that way I have a weekly cycle count, so, or a monthly cycle count of how many times we cycle things on and off. That's what I'll use digital sensor controls for. Termination sensor or termination click-ons, stuff like that. Fan delays, you could use digital sensor controls. Logic stuff, you're going to use more analog sensor controls than digital sensor controls, so you're going to see more of that. So I want to go over real quick how digital combiner. So if we go down to configured application, if we go back one, I meant to go add application. So we're going to go add or delete application. We're going to add an application. We're going to hit lookup. We're going to choose a digital combiner. Okay. A digital combiner is just combining digital points. So same thing, we got number of inputs. You're going to have 0 to 16. So you could combine a ton of inputs into one. So you have engineering units, whether it's on or it's off. So if you go to this and you hit lookup, so you have on or it's off, occupied or unoccupied, closed or open. So anything that's going to be digital. So you have all these: econ, no econ, fail, okay, true, false, phase loss, run, stop. Anything that is a digital point is going to be on here. Okay, so you have combination methods. If you look up, same thing. You have and, or, exclusively or, vote, first good, and select. So if you go to or, you hit the question mark. So we've gone over and or, vote. So this output will be on whenever a majority inputs are on. A majority is defined as greater than 50%. So, and then exclusively or, the output will be on when any or all inputs are on. However, when all of the inputs are on at the same time, the output will be off. So not one you're going to use a whole lot, but I mean, you still could. So we'll click out of here. So just like everything else, you have an alternative combination method. You have an emergency, out, whether it be stop, run, it's going to be whatever your engineering units are. You have an output on fail, so if this were to fail out, what the output was going to read. And then same thing, you have your enable. So inputs. So you have your digital inputs in. So you can do 16 on here. So if you had to combine a ton of inputs digitally on here, this is where you would do it. If you need more than 4. So this is like a revved up digital sensor control. I mean, it has less advanced features, but you're able to do more. So if you go down here and you were to choose 15, so you could do 15 inputs. Okay, so you have all these 15 inputs, so it's going to combine them all together. And then your control ends, so you have an alternative, invert output off, use alternative, emergency override, and then your output screen. So, I mean, this is you would then take this and use it for another application. Or, I mean, I'm going to be honest to you guys, I don't use a whole lot of these. I mean, the only time I've really ever used them is I had 5 suction groups on a rack, and I had a defrost differential valve, and I had hot gas on every single one. So instead of doing the defrost differential valve with the digital sensor control, I ended up using a digital combiner, where I ended up using a bunch of these. Lighting overrides, if you had a bunch of lighting zones or lighting proofs, I could see using them. Maybe some HVAC proofs, or like level sensors. It's just one thing you could have on there. I mean, there's not a whole lot of stuff we use them for, but they're still there. So we'll go over these in UltraSight real quick. So we'll exit out of here. So just like we did, we'll give a brief overview in UltraSight. So we're gonna, since we did all the programming on E2, even though it's in terminal mode, if we did it on the E2 too, we're gonna do a site synchronization. Okay, and we're gonna go to, close these guys up here, digital sensor control, and we'll look at these real quick. So defrost differential valve. Okay, so just like we had here, you have all the drop-down menus. Everything's the same in UltraSight. It's just a lot easier to do it. So you have your logic. You have all your stuff here. So logic N, same thing. You set up logging the same way you do with the analog sensor control. So tie it to the base log, hit apply, hit OK. It's a lot easier to do this on here. On the E2, you have to go to F3 edit and then go to setup logging. So you get your controls in, so your reset count, your alarm disable, your use alternative combination, your emergency override, your delays tab, your proofs tab. So same thing, you have your proof set up in here, your output, so your board point's going to go, or whatever it's controlling is going to go. So you can control multiple things off here. You can control board points, you can control other applications. It could be an input to another application. So we'll say you're doing some kind of like proofing with it. You could do that. Your counts, your pulses. So your level edge, like however you want to do your counting, whether it's on or it's off, or if it goes from off to on, or it's a change of state. You got your bypass in here. So your bypass value, whatever it's going to be. You got your alarm section, whether it's alarm, it's off, your alarm delays, power for the KW stuff, and then see the input-output screen on here. So like this is a lot easier. You get a lot more status out of here than you would on the E2. So you got your logic in, bypass values on, but your bypass input is not. So your bypass is not going to be on. So you come down here, first good, 1, cycle value off, cycles tripped off, command out off, bypass value on, so it's not bypassing. So you hit OK, you come out of here. So this is how it looks if you hit the graphical status in E2. You're again going to get that block logic screen. Sometimes this is a lot easier to look at, like with stuff like this. So, I mean, when if you do a lot of microthermal or RDM, and you're looking at like a lot of block logic, this is what you're going to see. Like you're going to see a combiner. You have everything in here, and everything's set up on here. So just like this, I mean, this is a lot harder for guys to look through. But one other thing I want to show you guys, if we go back to the tree. So this is some like other stuff, like my sump pump's on here. So I can go on here and look at my sump pump. So this is tied to my house technically. So if I go get logs and I look on here and see, I can see my sump pump alarm hasn't kicked on. I'm using a proof on there and all that. And then I have my sump pump run. So this would be looking at my sump pump. And if we get the logs in here, so this is looking at CT every time the sump pump comes on. So my sump pump hasn't come on. I live in it's the middle of winter time, so it isn't going to come on. And then well pump run. So another one. So you look at this one, get logs. This one may not even be set up. So this is my well pump cycling. So every time it comes on, it's going to proof it. So you can see between 8 and 9, it's coming on, coming off, coming on, coming off. So I'm using a CT or current transducer for that. So if we look at this one, edit application. So this actually comes from a Hawkeye, which is a current transducer. So every time it does it, it's proofing it on and off, and it's one way you could tell how many times things are cycling on and off. The one thing I will tell you is with digital stuff, whether it's a output or a digital sensor control, you're better off making a second log group and not putting it at the base log, so it isn't logging every 2 or 3 minutes. Because in that 2 or 3 minutes, you could be cycling that input on and off like multiple times. So you're better off putting a second log group and putting it to like 30 seconds, so that way your logs go a lot quicker. So that way, because you may not catch it in that 3 minutes going, so on and off. Well, guys, I appreciate you guys listening, and this is Digital Sensor Controls. The next one, we're going to go over basic moving around in the controller and how to graph multiple things at once and basic troubleshooting stuff in the controller. Thanks for watching, guys. I appreciate it.